Hi everyone, so my name's Gabby and I'm here to answer the essential question, how does electron configuration relate to the organization of matter? So first, what is electron configuration? Well, I'm going to break it down into 3 simple questions and hopefully that'll help kind of figure out what this is. So my questions are, what is it, how does it work, and what's the order? So first off, what is it? So electron configuration is the arrangement of electrons in an atom's orbital. So if you want to look at the actual configuration of electrons, this is what it looks like right here. And so how does it work? Right now this is just kind of a really long line of numbers and letters that make no sense. So let me explain what this actually means and hopefully it will make sense. So if we take the first little chunk here, which is 1s2, 1 represents the energy level. So there are 7 different energy levels. There's 1 through 7, like I just said, and so this spot can be taken up by any number between 1 and 7. The next little space is the s. S is the type of orbital it is. So there's 4 different types of orbitals, S, P, D, and F. So let me explain those real quick. So the S orbital looks like this, pretty, and it holds 2 electrons. The next one is P, and this one holds 6 electrons. The next is D, and that holds 10, it looks like that. And the last is F, and it looks like this. Looks like this. And it holds 14. Okay, now we're back to 1s2. So the little 2 that I haven't explained yet, this is the superscript. And it represents how many electrons are actually in the orbital. So this can be anything from 1 to the maximum number like the actual orbital can hold. So if you still don't understand that, that's fine. We can break it down together. So let's take another example. We'll use 2s1. So 2 is the energy level spot. So we're going to call it he. It's a he. He's in the second energy level okay. So he's second energy level. Next is s. S is the orbital type. Since it's an S, we know it can hold up to 2 electrons. So next we have the superscript up here, and that says 1. 1 means how many electrons are actually in the orbital. So we know that there's 1 electron in this orbital right now, but there's still room for 1 more. So now we need to answer, how is it ordered? Okay, so now that you know how to read this super long chain of numbers and letters and superscripts, we can see that it actually doesn't perfectly go from 1 to 7. So the reason for this is that electrons are lazy, they don't like to work. So if they can fill up lower energy levels first, they're going to do that. So to fill an energy level correctly, there needs to be 1 electron in each orbital. So say we're doing a p-type electron. There's 3 different orbitals in a p-type, so there needs to be at least 1 electron in each orbital before we can add more. And once there's 1 in each electron, we can start adding more, but they need to be the opposite spin. So if you look at this, there's a half arrow going up and a half arrow going down. So that just represents a different kind of spins. And that needs to be there for every type of electron in each pair. Okay, so because orbitals don't fill in order, we have to remember which orbitals go when, and that can be kind of hard unless you remember, or at least unless you memorize this. But there's actually a pretty easy way of remembering. And first what we have to do is write out our energy levels 1 through 7. And then we start from the top. and we write the different types of orbitals we can have. So it goes 1s, 2, 2s2, 2p6, and it just kind of goes on. So you add on one new orbital type until you get to the 5th energy level. And the reason it changes at the 5th one is that we run out of different types of orbitals to use. And so because we've run out, we go to the f orbital, and then we put in parentheses the next orbital, because that would be, that orbital doesn't exist. So we would have 5G after 5s, 5s. And then once we got to 6, the energy level 6, we would do the same thing, except it would be one less than 5. So that means that the 6th one only goes to the D type orbital. So then in the parentheses, we're going to have F and G. And then since it's supposed to be another energy level higher, we'll add a H. And then we just do the same thing for the 7th orbital, or 7th energy level. Okay, so now we've made like this cool little triangle dude, and now what we need to do is take diagonal lines and just slash through each of them diagonally. We just kind of slash up and down. And once we've made a triangle and slashed, we kind of just follow each of these lines, and we follow each of these lines and we write what we see. So we'd go 1s2, 2s2, 2p6, or 2p6, and then we just keep going down and start at the top again until we run out of stuff. So that's basically what electron configuration is. So now we need to figure out what organization of matter is. So organization of matter is the periodic table of elements, which looks like this. So now you take the electron configuration and you put it in the same order as the periodic table. And it's quite interesting because if you actually read from left to right and top from bottom, they match up perfectly. So we're not just putting the electron configuration in the same shape as the periodic table. The electron configuration is the same as the periodic table. So it's really cool that we can figure this out, and it's really interesting because if you look at the first two columns, this would be the S-type orbitals, and then the orbitals between 3 and 12 would be the D-type orbitals. Then 13 through 18 are the P, and the intertransition metals are the F-type. And it's really impressive that this actually all lines up so perfectly, because the men who made this periodic table didn't know the same stuff we did today. So it's really amazing that he could get that right, and that electron configuration order or pairs up so great with that. And so basically, to sum it all up, the periodic table is in the same order of energy levels and shells in the atoms as the electron configuration, making different notations and an easy way to organize both elements and electrons possible. Thank you.